3D Graphy News is a platform where we have both technology respondents and researchers to come and share their insights on a platform with content to be shared to the end users, and also end users coming with their expectations across sectors from aerospace to defense to drones, space technology and shipbuilding, and also medical and dental. Even bioprinting for that matter in terms of tissue engineering. So we have been in the forefront of sharing these insights, started this company in India and now globally ensuring that we can actually share these insights to the global world for everybody to be a part of this so that the ecosystem is set and ready. So today we have an opportunity also to get some great insights from a 3D technology expert. This has been our initiative within the 3D Graphy news space. We also have interviews from experts sharing their expertise on the subject so that it can be well connected to the end users and the audience. So today may I invite Dr. Yash Bandari, who has been a key respondent in 3D technology and also offering solutions in this space and with his research. Dr. Yash Bandari is an international recognized manufacturing engineering professional with more than 10 years of experience in metal 3D printing. Ladies and gentlemen, he has been in sales and rights proposal and a portfolio of projects as principal investigator and has provided technical guidance to the project team to deliver high quality results. He's one of the few individuals in the world to have experience with all the three heat source in additive manufacturing with reputed organizations working in US and UK and in India before he was 30. So he's also pursued his PhD from Cranfield University, UK, and worked at Oak Ridge National Lab, USA, and Edison Welding Institute, in short form it's also called EWI, before joining Additec, which is the co-founder of Meltio. So very good morning, Dr. Yash Bandari, and also a very good evening back in New York. And thanks for your time, Doctor, to also have your input share on the subject. My first question, Doctor, would be, 3D technology came by time. Now we also realize that this technology is gaining a lot of traction, globally it was, and now slowly and steadily across countries, people and companies are looking at these solutions when it comes to what it can offer, when it comes to additive manufacturing. So if I may ask you the first question, how it all started, Doctor, for you in additive manufacturing or 3D printing universally called?
Yes, a very good morning to the people in India, and it's almost midnight here in the US. First of all, thank you very much, Shibu, for having me on, and I'm very pleased to be on this show. So where it all started and how it all started, I can take you back to 2010 when I was doing my master's at IIT Bombay. I had a very good opportunity to work with a professor who was one of the few individuals at that point of time to have worked with metal additive manufacturing. So it was purely out of luck. I would say that I got into metal additive manufacturing. It was called rapid prototyping at that point, and then way back in 2010, additive manufacturing was just a buzzword. Everybody was talking about this 3D printing. Most of them were being used for making toys, these small-scale desktop printers, and that got me attracted, to see what's there in 3D printing and want to learn more about this process. So that's how I entered into 3D printing, and I had an opportunity to present my research work at an international conference in Singapore, and where out of, again, luck, I got for the first prize for the best paper award. And then I realized that 3D printing is not a flash in the pan, but instead it's a long it is something that'll be there for the next 100 years or so. So that's how I got motivated and interested in 3D printing, and especially what next. So the next big thing at that point was can we move this 3D printing technology, which was more on the prototyping and then making toys, to make it real life, to make real life components like mostly metals. So that got me interested into metal additive manufacturing, and at that point I was researching into different institutions, universities, where I can do, where I can learn and pursue my interests. And that's where I found Cranfield University. I read an article at that point where researchers at Cranfield University used um, a conventional welding process and then used it to build a large scale application out of titanium. And then they named that process as wire art additive manufacturing. And it was a very good fit with my master's thesis, and that's how I ended up at Cranfield University. Most of the people, they think that PhD is, basically doing something within the four walls, and people will be very shy talking to people. But it wasn't the case. In my scenario, it was more like a problem-solving course rather than basic science. I would like to be called. I would like to it to call more like applied science rather than basic science. And during that course of time, I had a very good opportunity to work on different industrial projects, the ones with Lockheed's, different other aerospace companies. And during this process, I was getting more close to the customer applications, and then I could understand the challenges and then understand the gaps. And I was successful in creating efficiencies and solutions for these type of problems in metal additive manufacturing. So that's when I attended again a conference in the US, where I found out about Oak Ridge National Lab, where they were setting up the metal additive manufacturing, and especially the large scale additive. And and I thought there's a big market in the US where there are a lot of customers who can benefit with the background that I can provide. So leveraging my background, I landed up a position at Oak Ridge National Lab, where I was instrumental in understanding other DED processes compared to my PhD, and I was instrumental in taking the TRL and MRL levels to from 3 to 5 during that process. And then during my tenure at Oak Ridge National Lab, I was pretty much confined, with a few customers. But I always wanted to take this additive manufacturing to the real life scenario, make it more industrialized, and that's how I ended up, at Edison Welding Institute. It was a very good platform to understand different customers' challenges, and it gave me an opportunity to work on different additive processes, thereby comparing, what are the good things and what are the limitations of different additive processes. And now I'm in a very good position to guide the right people, to guide people to the right additive processes, which makes sense from the cost and time standpoint. So right now, at Additive Technologies, which is a co-founder of Meltio, I handle the business side of it, both on the sales and then on the project management. And then I help customers to solve their problems. And then at each additive manufacturer, I talk to a different broad range of customers, where we discuss and we crunch down the numbers and see if additive makes sense. If additive makes sense, and then what about our process? So these are a couple of things I do at the moment. But I've been having a really roller coaster ride at Additec/Meltio, and we have been doing I think a lot of good work and industrializing this additive manufacturing process.
So that's also about Additec. That was my next question to you. What is the scale and the size of the business that Additec does, and what are the specializations? Which I think you covered almost a bit of it, yeah.
Yeah, Additec, as I mentioned, it's a co-founder of Meltio. It's a wholly US-based company, founded in 2015. Right from day one, the main goal or motto of Additec was to um, um, change the way how conventional manufacturing is done. Because the conventional manufacturing, in most of the scenarios that we are coming to know, that it is highly expensive and it takes a lot of lead time. So can we change? Can we change? Was the first question, and can we come up with some reliable systems, which are nice, rigid, not work for like few years, but can be used for several years, and then build the real life engineering structure components. So right from 2015 until 2019, over the course of time, Additec patented laser metal deposition process, where a user can use either wire and or powder independently or simultaneously. Most of the systems in the additive market, they either can apply either wire or powder, but there's no system that leverages the advantages of both wire and powder. So Additec is the first company that filed the patent and successfully got it. And you need a lot of capital to commercialize your prototypes technology. So that's where it formed a joint venture with another Spanish company, and formed a joint venture named Meltio in 2019. So over the course of last 3 years or so, Meltio has been very successful in promoting the technology and basically building reliable systems where a user can build real-life engineering structure components.
Great. So for the sake of the audience, Dr. Yashwant, if you can explain a bit more on LMD, laser metal deposition technology, and its advantages.
Absolutely. So laser metal deposition, LMD, is not a novel process anymore. It has been there in the market for about 30 to 35 years. But in LMD process, powder has been used as the feedstock primarily over the past 30-35 years. So in any process, there are three constituents. The first constituent is a heat source. So here in LMD process, as the name suggests, it's laser is a heat source, and the feedstock. In traditional LMD process is powder, and then the third constituent is the motion control. So how do you create the tool path, or how do you build the process? So in traditional LMD process, laser is the heat source, and then the powder is the feedstock, and then the motion control, it is primarily a gantry-based system. So the advantage of LMD process is since you're using lasers, you have a nice spot size where you're able to concentrate your heat input, as opposed to other heat sources where you don't have any spot size, and then you're putting too much energy in, which might give a lot of distortions or stresses, or even defects in some cases. So this is one of the advantages of lasers. Probably this is one of the reasons why a lot of processes in additive use laser as the heat source. So we still stuck to laser because of these advantages. And one of the key things about lasers is because since it uses an engineered spot size where you're concentrating the heat, it gives better surface finish compared to other heat sources. So in our process, LMD, in addition to powder, there's also a provision to apply wire as the feedstock. Why wire? As in, wire is the most safest feedstock in the additive, and it is 100% material efficient. So what I mean by 100% material efficient is the feedstock gets consumed 100%, and you can see the printed part, as opposed to about 50 to 60% if you're lucky. In case of powders, and then the rest of the powder needs to be recycled, or it goes into the trash. But again, powders have a unique advantage of using less heat input compared to wires, so that gives additional advantages when it comes to repair applications, mixing powders, and all of the good things that comes with powder. Only if you don't find a material in the form of wire, we advise our customers to use powder. And even the productivity with wire is at least 3 to 4 times more when you compare with powder. So yeah, these are the advantages of LMD process, and more specifically, Meltio's LMD wire powder process.
One very, very important aspect is also, doctor, that the lactic structure. Maybe that is something that will not be able to achieve with LMD in a way. But how is it useful, and which are the sectors and industries where this technology can be useful? For example, if I'm looking at a design with the lactic structure, maybe in the industries like aerospace. But not necessary that every structure needs to be having a lactic structure. But where all it can be used with LMD, so it can be a mixed combination of various appliances and applications. So I'm just trying to understand which are the sectors where this technology can be very, very useful.
Absolutely. So under metal additive manufacturing, there are two main processes. One is powder bed fusion processes, and the other is DED process. So this LMD process comes under a DED process. Like in my experience, DED and powder bed, these two processes, they complement each other. So both of them, they have their own niche applications. Like for example, you got a good topic about lattice structures. So these lattice structures, they're very fine in structures, and then they're small in size, and also they require supports conventionally. So for those kind of scenarios, I think powder bed processes might be a good fit. But on the other side, DED processes, they are traditionally used to build little larger in size components, which can be fitted on powder bed technologies, and then large size, large scale components, which are definitely not possible on powder bed technologies, and then which can be only printed as opposed to doing it in a conventional manner because of long lead times and and a high cost involved. So coming back to the applications, coming back to the industries, I think LMD process is versatile. In one word, it is versatile. So what I mean by versatile is as long as you're able to find a geometry where a process like LMD makes sense from both cost and standpoint, I think it can be applied. I talk to a lot of people who come up with some CAD models and they say, hey, can you print this part? In some scenarios, we can print the part, but it does not make sense from a cost standpoint. And then in some scenarios, yes, we are able to print that part. We are not able to find a material which exactly matches. So this is one of the good things about additive manufacture, where you don't have to replace like to like when it comes to castings or forgings. You can develop a new material or very close to the material that we can find in additive process, and then build up the part, and then get improved properties. So yeah, so this way there are many applications in casting, forging, dissector companies where LMD can be used as a good process. And then traditionally, aerospace industries, they have been forefront runners when it comes to additive manufacture in general. Most of these aerospace parts are out of titanium alloys, nickel-based alloys, and aluminum alloys. Like for me, titaniums and nickel-based alloys, they automatically create a business case because most of the aerospace components they are hollow, and then it involves high buy-to-fly ratios. So in order to tackle this, I think LMD process is a very good process which can save long lead times when it comes to castings, and then it creates a very good business case. And last but not least, I would also say that LMD process has gained a lot of traction in space applications as well, because that's the cool thing right now, just going on in space, where instead of assembling thousands and thousands of components in a rocket, can we print only a few components, which will reduce the overall weight of the rocket itself and avoid joining the processes. So this is one of cool applications that LMD can be applied, and we're also working with some jewelry industries actually. So this is which I don't think a lot of DD people have explored. And just last week itself, we did a press release on how we are, printing medical components which cannot be done in a conventional manner using our wire and powder technology. So yeah, so I think in a nutshell, as long as you're able to find a geometry, you're able to find a material for that geometry, and you're able to create a business case, then I don't think a sector has to be defined. Any sector where you can find a material geometry which creates a business case, I think LMD process can be applied.
Amazing. And also, Dr. Yashwant, because interesting thing is also with the technology now, with the hybrid kind of a model, you can also work. One is, yes, with the wire, it's more accessible, it's available. As you rightly mentioned about the cost can be most cheaper, and so it depends upon application to application. I also know a fact that a team of experts are also now working on femur implants for orthopedics. So when it comes to the wire, they are using this titanium grade to get the femur done, and the serrations can also be done with the CNC part. So a hybrid model can be really made well utilized with this technology is also what we understand. So how do you share your expertise on the hybrid model where this can benefit, and what will be the advantage for the plants and machinery companies?
Yeah, absolutely. So hybrid applications, hybrid manufacturing is one of the evolving and upcoming process in metal additive manufacture. So hybrid manufacturing involves more than one process. So it could be additive plus additive, or it could be additive plus subtractive, or it could be additive plus any other process. So all of them, they fall into the hybrid category. But most well-known hybrid process is additive plus subtractive, where you can do both additive and subtractive inside the same system. So what's the motivation of this process itself? Because most of the additive processes, most of the additive parts, they're not 100%, the best in terms of surface finish. And even in terms of tolerances, they're not close to microns, which the specs say. So how can we print parts which are, which look like mirror-like surface finish, and also you get the tolerances similar to CNC. So adding subtractive to a already existing CNC or a new CNC can check all these boxes. So even in one of our systems that we sell, which we call it as hybrid manufacturing, where we integrate our additive module, which comes with the heat source and then the laser head to an already existing CNC or a new CNC, and a more additive system that can do additive and subtractive on the same platform. The advantages of these are you're saving a lot of time, because you can do additive, but then it has to be transferred to a CNC system. So a lot of people, they don't have expertise on the CNC, so that means they have to outsource it. So this involves a lot of time. So can we do everything on the same platform where moving between parts can be reduced? Is something hybrid manufacturing will help. So if you have a 5-axis hybrid system, is the best system in my opinion, which can print crazy components like conforming cooling channels, which is very difficult through conventional manufacturing or even through additive manufacture. So good thing about hybrid manufacturing is you can do additive and subtractive back and forth depending upon the geometry of the part, like this conforming cooling channel, where it is very difficult to machine once you print it. But you can do both additive and subtractive, and then back and forth, for these type of applications, where at the end of printing process itself, you're able to final finish and you're getting the more qualified part. There might be some applications where you might do some heat treatment after additive. It can also be done, where you print it and then take it to an oven, heat treat it, get it back, and then you're not changing the work envelope. So, in my view, hybrid manufacturing is still an evolving process, because it requires two processes, additive and subtractive. And then how do you design the tool paths for additive, or you do design the tool paths for subtractive? Would you use two different softwares, or how do you move from one process to other process? So these are a couple of bottlenecks, but I think there's still a lot of areas that need to be tapped, and there's a lot of possibilities and avenues for hybrid manufacturing processes.
Also, that we talk about how this technology can gain more traction. I think we all believe that education and training, starting in engineering institutes, will be a very, very important and relevant initiative in that direction, Dr. Yashwant. So how do you actually try and see that you can connect these dots? So do you also actively conduct these sessions to educate the new aspirants, also to ensure that this will be a prospective way of also human resource, because that's going to be something which is very, very important and relevant, and especially when it comes to a learning pattern on with design for additive manufacturing becomes a completely new area of specialization for institutes and also students to learn, with material size, of course. So how do you try and address that particular aspect?
Yeah, that's a very good question. I get asked this question a lot of times. For me, higher education is the starting point for additive manufacture. And higher education needs to work, like industry and academia need to work together to develop and train the next generation of additive manufacturing talent. As we all know, 3D printing is transforming the way how we look at the products and the way of manufacturing, but it is lacking the qualification here. The QA and QCs is still haunting additive manufacturing today. So commercializing these products and the scaling additive manufacturing into large production facilities, it requires knowledge in two distinct areas. First, you need to have knowledge in the product and also the process. So as AM becomes more powerful and increasingly complex, one missing piece has emerged, that they need nice staff. The companies need staff support in leveraging this solution on demand. So this has created the missing link, I would say, why additive manufacturing is not yet adopted by everybody. So the staff needs to be created. So where can this staff be created? It's only from the universities, the research organizations, the academia is the thing. But at the same time, having industry experience, having a bookish knowledge is very good, but you gotta apply it on the real world. So this industry, the bridging the gap between industry and academia has to be worked out, has to be done. I've been seeing a tremendous, difference in how industry and academia are working today compared to what it has been like 10 years before. So you got to understand the issues, the opportunities, where both industries and academia face. Got to shape up, the AIM professionals. So all these will be really important. Actually, I'm actually on panels on many of these, SMEs. We have a professional body in the US, SME, which does a lot of trainings for the universities and graduate students, and then create the real life scenarios. Even at Additec, we are very much mindful of it, and even last month or so, we have been inviting a lot of high school to the university graduates to come have a look at our systems, learn. So this is something which would like to give back to the society, and I think these are very important in shaping up the future talent.
Very true, Doctor. Doctor, and also one important thing that I also wanted to know in terms of what is the penetration that you have been able to do with Additive, because that's also a key important factor. So, Additec, as in how many countries are we actually currently operational?
Yeah, Additec, is actually a subset of Meltio. It's a co-founder, and then right from day one, Meltio's business model was to create a lot of entities in different territories that can act and then promote Meltio's technology and then work with the end users. So since we are the co-founders of Meltio, it was a no-brainer that in North America, it'll be Additec that with the end users promoting Meltio's technology. So Canada and the US have been are where we are operating and then working with our end users. Just really in terms of numbers, we sold close to 40 systems. In the US and Canada combined together, that comprises of all the three Meltio products. But primarily the US is a big market, and US has always been a forefront runner when it comes to metal additive manufacturing.
Thank you so much, Doctor, for your insightful thoughts in terms of sharing what all is really the need of the hour. One, to also share what the technology can do and which are the sectors that it can benefit, and what are the processes that are involved in terms of what Additec has been actively doing so. And also then the institutional tie-ups, which is very, very important, because we need to fill that gaps. That's something very, very important for us to see that how we can take this technology to the next level. And thanks for your time, Doctor. And it was a pleasure connecting with you. And also we'll keep in touch with you with also the inputs and the content from your side. So it will be a great learning for all of us to benefit from this interaction and our communication. Thank you so much for your time, and see you soon, sir. Thank you so much.
Yeah, absolutely. Thank you very much for having me on your show, and thanks for taking the time to talk to me. I really enjoyed the show, and I look forward to watching more of your shows soon. Thank you.
Thank you so much. Thank you. Bye.